Hello everyone, my name is Alberto Elizalde. Today I'm going to present the work titled Comparative Study of Hydroalcoholic Extracts from Vaccinium Leucanthum obtained by ultrasound-assisted extraction and maceration for the green synthesis of gold nanoparticles. This project is the result of a collaboration between the Universidad Tecnológica de Querétaro and Centro de Física Aplicada y Tecnología Avanzada at Universidad Nacional Autónoma de México. As introduction, Vaccinium leucanthum, colloquially known as cahuiche, is an endemic fruit of Mexico. We find it mainly in the forested regions of Omitlan de Juárez in the state of Hidalgo. Initially, we know that this fruit possesses high antioxidant properties like other similar berries. However, being an endemic species, its bioactive profile is largely unexplored in scientific literature. Therefore, in this work, we set an ambitious goal to conduct a systematic and comprehensive evaluation of this bioactive profile. But we didn't want to stop solely at the botanical characterization. We wanted to take it into nanotechnology applications. Our main objective was to identify the optimal extraction conditions that would allow us to obtain an extract rich in functional and compounds ideal for use them as a reduction and stabilizing agent in the green synthesis of gold nanoparticles. But why gold nanoparticles? Because in the future, we want to use them as vehicles to explore the properties that the cahuiche compounds can offer for biomedical applications. To achieve this objective, we designed a methodology divided into four main stages, which you can observe here in this diagram. First, the pre-treatment of the biomass. Once the cahuiche was collected, we obtained a pulp that we standardized and lyophilized by freeze-dried. This lyophilization is a crucial step because it allows to keep all the thermodynamic phytochemicals of the plant intact. We stored this powder at low temperature at 4 to 6 Celsius degrees in polypropylene containers. The second stage is the core of the study, the comparative extraction process. We used solvent systems pre-acidified to pH 3 with citric acid, evaluating three media: dionysic water, a hydroalcoholic water ethanol mixture at 70 to 30 volume ratio, and pure ethanol. Maintaining a solid to liquid ratio of 1 to 10, we compared two distinct physical phenomena. Ultrasound-assisted extraction, evaluated at 5, 10, and 15 minutes, which is based on the kinetic degradation of bioacoustic cavitation, and as a reference, traditional passive maceration left for 7 days at room temperature in total darkness, which works by simple passive diffusion. In the third stage, the extracts were vacuum filtered and lyophilized again to evaluate the exact yield and to work with the standardized concentrations for different evaluations. For example, the quantification of phenols, flavonoids, total sugar content, reduction sugar, and other important parameters of the extract. And finally, we work with a standardized concentration. In this case, was 10 milligrams per milliliter. That's the concentration of the extract that we work. And finally, with the optimized extract, it means that we select the most efficient process to obtain the extract with the most balanced properties. We proceed to the green synthesis of gold nanoparticles. The reaction was carried out by injecting the reconstituted lyophilized extract directly into a solution of chloruric acid, which have a concentration of 5 millimolar. This at room temperature using a rapid one-shot injection. Subsequently, the mixture was left in a static maturation for 24 hours in complete darkness to preserve the photolabile phytochemicals acting on the nanoparticles surface. Okay, so moving on the preliminary results, as you can be seen in table 1 and figure 1, first we characterized the fruit itself. We found a very competitive initial total phenolic content and a remarkable anthocyanin content in the fruits. Figure 1 shows us the representation in the C-lab color space, confirming that characteristic dark purple tone is strongly associated with the high presence of anthocyanins in the fruit. But the most interesting part of these results occurs when we compare the extraction methods. In these graphs in figure 2, we evaluate the antioxidant capacity using DPPH and Comparative methods, as well as the flavonoid, phenol, and anthocyanin content. As you can notice, there is a very clear trend to binary hydroalcoholic mixture, water, ethanol, consistently outperforming the pure solvents. Furthermore, it is fascinating to observe the effect of the time and the method. Short ultrasound treatments, 5 to 10 minutes, manage the exact phenolic compounds in amounts equivalent or even higher than what we achieve in the 7 full days of passive maceration. The synergy between the solvent polarity and the acoustic energy of the ultrasound is evident in all the results. To summarize this vast amount of data, we generated these multiparametric phytochemical fingerprints in figure 3. The central polygon, this corresponding to the water to ethanol mixture, and is noticeably to broadest and most balanced of the three. This confirmed to use that this and specific exact offer the perfect balance of reducing the capacity to transform the gold from an ionic to a metallic state and stabilizing capacity to prevent the nanoparticles agglomeration, because we had the high antioxidant capacity and higher content on phenolic and flavonoid compounds in the extract, which are essential for the green synthesis of different nanoparticles. However, it also reveals that for applications where the specific extraction of anthocyanin is the main objective, the use of pure ethanol is the best option, okay, to isolate high quantity of anthocyanins. Once this optimal extract, the water ethanol extract, was selected, we apply it to our green synthesis of gold nanoparticles. In figure 4, as you can observe, the micrographs from scanning electron microscopy, we managed to produce gold nanoparticles with a spherical morphology, highly homogeneous, and with very narrow side distribution, as you can see in this graph. And this is an indicator of a high controlled synthesis. Additionally, the X-ray diffraction pattern in figure 4b uniquely confirms the face-centered cubic crystals structure typical of gold nanoparticles. Okay, so in conclusion, the recovery of phytochemicals from cahuiche is highly tunable. It depends on a synergistic interaction between the solvent polarity and the extraction time. We proved that short times with ultrasound in hydroalcoholic mixture are the most efficient way to mobilize the phenolic compounds of this endemic plant, and most important for our long-term goal, this comprehensive phytochemical recovery makes our hydroalcoholic cahuiche extract an extraordinarily effective and balanced reduction and capping medium for the green synthesis of gold nanoparticles. So thank you all. Thank you very much for your attention. If you have any technical question about the project, I will be happy to answer them.